In this video, I will talk to you about Faraday's law of induction and what factors influence the magnitude of EMF induced. A change in magnetic flux through the loop will induce an EMF, producing a voltage that will light up this light bulb. No matter how the change is produced, the voltage will be generated. The change in magnetic flux could be produced in several ways. Right now, the strength of the magnet is at 50% and there are currently two loop wires. Closely look at the light bulb as I move the magnet through the loop of wires at a slow pace at first. Now, look at the light bulb again as I move the magnet through the coils of wire at a faster pace this time. As you clearly saw, the light bulb was a lot brighter when I moved the magnet through the loops of wire at a faster pace. Michael Faraday found out that the more rapidly the magnetic field changes, the greater the induced EMF. Faraday also found out that the induced EMF depends on the area of the circuit loop. Now I'm going to increase the area of the loop from 50% to 100%. And closely look at the light bulb as I move the magnet through the loops of wire. Now I'm going to shrink the area of the loop from 100% to 50%. And closely look at the light bulb once more as I move the magnet through it. The EMF induced is proportional to the rate of change of the magnetic flux passing through the circuit or the loop of area. Now, I am going to increase the strength of the magnet from 50% to 100%. And closely look at the light bulb as I move the magnet through the loops of wire this time at a slow pace. Now, I am going to decrease the strength of the magnet from 100% to 20%. And closely look at the light bulb again. It shows that the stronger the magnet is, as I moved it through the coils of wire, the more it induces EMF. Now I am going to show you another way to create a change in magnetic flux. Here we have an electromagnet currently at 5 volts. Now I am going to move it through the loops of wire and look at the light bulb closely. Now I am going to increase the voltage from 5 to 10 volts and look at the light bulb closely as I move it through the loops of wire. As you clearly saw, increasing the voltage of this electromagnet induces a greater EMF. So now I will show you the last way to create a change in magnetic flux inducing EMF. Currently there are 2 loops of wires and the strength of the magnet is now at 75%. If we rotate this loop in a constant magnetic field, we would induce EMF, but in this case we will rotate the magnet and it will produce the same effect. So let's get started and rotate the magnet at 50 RPMs. As you can clearly see, the light bulb is fairly bright, but if we increase the rotation of the magnet, we would induce a greater EMF. So now let's increase the rotation from 50 to 100%. As you can clearly see, the light bulb is way brighter. So now let's turn it off. So a quick recap. A change in magnetic flux through a loop will induce EMF, and EMF is proportional to the rate of change of magnetic flux. I hope that you were able to understand all of this, and thanks for watching.